Hello, good evening, everybody. Hello to all the warriors who are going to give this CBSE board exam this year. I'm sure your preparations are going great. As the CBSE exam is just a couple of months away, so I'm here to present one revision session for you guys. Well, before starting that, about me, my name is Ravi, and I've been teaching physics for past 10 years, a competitive level physics, where we prepare for competition exams. And for past 10 years I've been teaching physics, as I just told you. So well, today we'll be taking this topic called electricity. All right, well, and well, this topic is very important for the board exams. All right, I work for Diksha Vedantu, and let's go on with the topic. This topic has a very high weightage, and this session will be useful for everybody who's going for this year board exams. All right, so stay till the end so that you learn and you take on some things in the end. You know, for your board exams, when you're going for the board exams, you're taking something on home. All right, so let's start our topic for electricity. All right, okay, so okay, let me select the pen and let's go ahead with the topic. All right, guys, okay, this will be a 1 hour session. By the way, for everyone, just for your knowledge, we will be dividing this chapter into 2 parts. First part will be done today. Second part live will be on Monday evening, same time. So please keep on with that. Today we'll take 1 hour of class. Monday 1 hour class will cover up the revision session of electricity part. All right, having said that, let's start this chapter. All right, so electricity, what is it all about? What is this chapter all about? Let's understand this first. Okay, this is a very important chapter, guys. Weightage is very high. So since the weightage is very high and questions are easy in nature, just a very small formula based, 2-3 very small formulas here and there, and you can solve the problems. The weightage is very high, formula based problem, it can be easily done, very easy to do. So let's go ahead and start our chapter, electricity. Okay, all right, so this is about physics. That's all. All right, guys, you have this thing on your screen. I want you to have a very careful look on this. This cartoon that you see on your screen, this explains about this chapter, everything about this chapter, what's happening over here. You see over here, these 3 guys, what these 3 guys are doing. One guy is trying to, this green one is trying to pass through one very narrow pipe. The red one is trying to make it more narrower, is trying to pull with the rope, and there is one yellow one which is pushing it. This is exactly what happens in this chapter. If you understand this particular animation, this photo, you can understand this chapter. So let me explain you about it. What happens? This is our current. The green guy is our current. So current is trying to pass. This is our resistance. This is our resistance. This guy is resistance. Okay. All right. So the job of resistance is to stop the current, to oppose the current. The job of the resistance is to stop the current, to oppose the current. And the job of voltage is to push the current so that current goes forward. So this depiction of this particular thing, if you understand it, this will be very good. Now you understand, in fact, half of it. So again, current is trying to pass through, resistance is trying to stop, voltage is helping it. Having said that, let's go and hit the topic. Let's go forward with that. All right, so a little bit of some theory part. Whatever I'm going to show you guys is going to be very helpful for your board exams. Questions will directly come from this. Questions will directly come. I'll show you the pointers. I'll explain you the things wherever it is required, and questions will directly come. All right, so let's go ahead and understand the topic. After seeing this, current is going to pass through, resistance is stopping it, the job of voltage is pushing it. All right, let's go start. So little bit about synopsis. Now what is the synopsis is about? So this is about electric current. Now what exactly is the electric current? How will you answer in the exam? Okay, it is a flow of electrons through a conductor. So whenever there are flow of electrons in a conductor, whenever there is a flow of electrons in a conductor, electric current is produced. the direction of electric current is opposite to that of electron flow. So let's say if electrons are flowing from left to right, the current will be in the opposite direction. This is how we find out the direction of flow. Second is, okay, the device which causes the flow of electron through a conductor is called cell. Guys, these things that you see, these pointers that you see, 1 mark question or MCQs, even in short answer questions, they may ask you the definition of this. So please take a screenshot, okay, please take a screenshot of it, please understand it, please see it, because these pointers are taken from past year questions. So these pointers are very important for you guys. Please have a look. I'll go one by one, easy. Okay, what is a cell? I just told you. Electron flow from negative terminal to positive terminal. This is important one. The electron flow from negative to positive terminal. Okay, electric current flows from the positive terminal to the negative. As I said, electric current is opposite to the flow of electron. This is how it works. All right. All right. So what is most important in this part is SI unit of electric charge, which is Coulomb. So SI unit of electric charge is Coulomb. SI unit of current is ampere. These two are important. These two are asked in your MCQs questions. Okay. So 1 mark question, short answer questions. They may ask you anyone from it, and your job is just to explain it. How does it go? I hope everything is going well over here. Okay. So people are able to understand it, right? Yeah. Okay. So now 1 ampere is that. Now definition of an ampere is also very important. So in fact, just 2-3 years back, there was a question which came. It asked about what define ampere. So you have to define ampere as given over here. Yeah, thoda sa just rectify like parrot and all, guys. It's very easy. It's not difficult. Okay. So first is SI unit. This is an important part. Second is 1 ampere is the current flowing through a conductor if 1 coulomb of charge flows through it in 1 second. It means there is a conductor. When 1 coulomb of charge passes through that in 1 second, 1 coulomb of charge passes through that in 1 second, we call it 1 ampere. That's it. You have to just remember this definition directly as it is, write it as it is and get the marks. This is how it works. All right, board exams are just over there, round the corner. I hope your preparations are going well, by the way. Okay, if not, pull up your socks. There's still time. Still, in next couple of months, you can do it. Okay, you can visit our website. You can see all the videos over here. Everything is available on our website, and you can go through with that. You can learn a lot of things from here. Let's go. Let's go ahead and. Okay, electric current is measured by an ammeter. Okay, this question also came in MCQ. How does an electric current is measured? It's measured by an instrument called ammeter. This is a very, I think 7th, 8th, 9th standard student also study this. It's not very great, but these things are asked in board exams. You can't help it. So you got to do. So these are the pointers which are very important. Okay, among that, the most important one I just told you, SI unit of electric charge, SI unit of current, definition of 1 ampere. These are very important. The direction of current is opposite to the direction of electron flow. Okay, so these are the takeaways from this particular thing. Okay, now let's go and okay, we have seen this. So what's happening over here? Let me show you guys. Let me give you one visualization so that you can visualize, and let's see what is going on over here. So let's say there is a conductor. We are taking a cylindrical type conductor. It looks like cylinders. There is a conductor. Okay. Now electrons, there are free electrons in this conductor. Free electrons. There are free electrons. There are free electrons. There are free electrons in this conductor. Okay. Now these electrons, when they start to move in one particular direction, all of them are moving in one direction. All of them are moving in one direction. That means we call that the current is flowing, and the direction of current is opposite to the direction of flow of electron. So we say current is from, let's say this point, this is A, this is B. So electrons are flowing from A to B, current is flowing from B to A. This is how we say that. This is how. Electrons are negatively charged particles. Electrons are negatively charged particles. It goes from let's say from A to B, electric current will be flowing from B to A. I hope this part is absolutely clear. All right. Okay, yes, hi. Okay, welcome. We are doing this this particular thing. Let's go. All right. Okay, so next part of the synopsis is electrical potential and potential difference. Okay, so what is electrical potential? Guys, just understand the electrical potential in this way. Electrical potential in this way. Please understand this part. First, let me give you the textbook definition, then I'll explain you what is electrical potential. All right. So electric current will flow through a conductor only if there is a difference in electrical potential. First thing you need to understand this. It means if the potential difference is not there, if there is no potential difference, there will be no electric current. I repeat again, if there is a potential difference, then only the electric current can flow. This question can be asked in your CBSE board exam, especially in short answer questions. Sometime in long answer question, they put 2-3 questions all together and you have to answer. I hope everybody knows short answer question should be answered within like 30-40 words, maximum 50. Don't go beyond that because you will be wasting your time otherwise. You won't be able to complete your paper. And long answer question should be like 80 to 100 words. Don't go beyond 100. Okay. So, and MCQs, everybody knows, it's just one tick mark and go. This is how it works. All right. So let's go with our electrical potential part. So electric current will flow through a conductor only if there is potential difference. Otherwise, electric current will not flow. Okay. Now, second is this difference of electric potential between the two ends of conductor is called potential difference. I'll explain you. I'll show you how it works. Okay, I'll explain you now. Let me first explain this, what is written over here. The difference in electric potential between the two ends of a conductor is called potential difference. Okay, so let me just explain you what I mean to say. Let's say, think about it. There are two buckets. Okay, let me start from this corner. All right, so let's say there are two buckets of water connected to each other. There is one, there is another one. These both have water inside up till this height, and they both have water at the same height and they are connected to each other. Now tell me one thing. If this is the case, if this thing happens, will there be any flow in water? Will there be any flow in water? Condition is this is bucket A, bucket B, both are filled up to same level and both are connected. So same level, connected, will there be any flow of water? No, there will not be any flow of water. To flow, one bucket has to be less than the other bucket. Okay, so let me just put it over here. All right, so this will look like the water over here let's say till here. Okay, and the water level is still here in this case. Now both are connected. Now what will happen? Now we will have flow of water. Now this flow of water, you can just relate it with the potential part. The level of the water we can call potential. So potential, level of water. Just understanding purpose, guys, okay? Level of water. So level of water. So instead of calling level of water, if I say the potential in bucket A and potential in bucket B, both are same, the flow of water we can call current. So if the level of bucket A, that is potential of bucket A, potential of bucket B, both are same, there will be no flow of current. So for current to flow, there must be a difference in level or difference in potential. I hope everybody can understand this over here. I hope this is absolutely clear, right? Yes, absolutely. Thank you very much. All right. Now, this is your A, this is B. All right. Now, the level over here is higher than level over here, and now the water will flow. And similar way, if the potential difference is there, then only the current flows, otherwise current doesn't flow. Please make sure everybody knows that. It's absolutely clear. Yeah, absolutely clear. Perfect. All right, so let's go back over this part. Okay, now next part is potential difference in a circuit. Okay, now one thing I want to tell you is, what is potential difference? So let's say potential in A is PA. Potential means level of the water. Potential in B is PB. So potential difference is PA minus PB. That's it. This is how we calculate it. Potential difference is nothing but difference of potential between 2 points. All right, let's go back to this slide. Okay, the potential difference in a circuit is provided by cell or battery. So where this potential difference comes from? From where it comes from? It comes from cell or a battery. Okay, battery is nothing but combination of cells. When we have more than 2 cells, we call a battery. One single cell is cell. More than 2 cells in series or parallel or anywhere, we'll discuss series and parallel, is called battery. All right. Now, potential difference in circuit is provided by cell or battery. And in battery, what happens? In battery, there is a chemical reaction takes place. That chemical reaction, what it does? That chemical reaction, it produces the potential difference between the 2 terminals, and the electron starts to move and electric current starts to flow. So what's happening here? So there is a battery. In battery, inside the battery, there is a chemical reaction. There is acid over there, hydrochloric acid, there are sulfuric acid, there are different acids which are used. Okay, so these acids over there, and they carry out certain chemical reaction. I will not go into chemistry part because this is a physics class. So the chemical reactions takes place there, and because of that chemical reaction, the electron starts to flow. That flow of electron causes the potential difference between the 2 terminal and current. This is how it works. Okay, I hope it's clear to everybody. I hope, yes, your comment is, I would appreciate your comment, guys. If you're listening to me, please comment that you like it. Yes, thank you very much. Please, everybody, if you want to ask me any question over here, I'm all here. Yeah, and you can, and also you can, those people who are watching it late, you can leave your comment in the comment section. I will come back to you. I'll reply you in person. All right. So for now, let's go forward. Let's understand what's going on over here. Now, next part is again potential difference. You see, potential difference is a very important topic. Every year you have a question from potential difference. Every single year. All right. So you can't take this lightly. It's a very small topic. It's a very easy topic. Just understand those buckets of water and you can understand the potential difference. It is that easy. Okay. Now it is potential. What is potential difference? It is between 2 points A and B of a conductor is the amount of work done to move a unit charge. This is the definition you have to remember like a parrot. You have to cram it like a parrot. I can't help it. This is the textbook definition. What is it? I can just explain you in technical terms. What is potential difference? It says that when we take 1 unit charge, it is the amount of work done required to move 1 unit charge. That's it. Okay, so this one you have to remember. What is the SI unit? Again, SI units of everything is so important because SI unit, this is a favorite question for MCQs. So whenever you go for MCQ, there are about 10 questions in MCQ. 1 question is very likely from SI units, and SI unit of potential difference is volt. Okay, and what is 1 volt? Definition of 1 volt. So what is most important? Definition of ampere and definition of volt is most important. All right, so what is the definition of 1 volt? 1 volt is the potential difference when 1 joule of work is done to move a charge of 1 coulomb from one point to another. Please take a screenshot of this. Yeah, please take a screenshot of this slide and understand it. Remember it. These are the pointers which are extremely important for your CBSE board exam. All these pointers that you see, they all have come in some point in the past. So past year questions are very important for any exams, guys. If you're preparing for any exam, past year questions are something that you should start. In fact, those guys who have just, let's say, I know there are so many people who don't study, they like to study in the last months, last 3 months, last 4 months, like that. Okay. See, marks are very important in 10th board. Marks are very important. It will be after you for your entire life. Wherever you, let's say you go after 10 years, 10 years after the, let's say after 10 years, you go anywhere, they will ask you, okay, how much did you score in 10th? This is what they're going to ask you. So your job is to score as high as possible, and science is a subject where you can go highest, where even you can even hit near to centuries, like late 80s or 90s, like that. Same like maths. Okay, science is easier than maths, let me tell you this, when you want to score really high over there. All right, I hope everybody would be okay with me over here. Do you agree with me or not? All of you? Yeah, I'm sure everybody would be agree with you, right? Okay, so potential difference, let's come back to our topic, potential difference. Okay, so potential difference is measured by voltmeter. This question also has come. Yeah, potential difference is measured by voltmeter, and it is always connected to parallel across the 2 point between which the potential difference is measured. Okay, what is the meaning of parallel? When we say parallel, okay, let me give you guys some thing over here. What is the meaning of parallel when I say parallel? Okay, let me just plot it over here, change the color. Okay, blue, let's see, blue is working fine. Okay, let me tell you parallel. Okay, let's say this point is A. Let me tell you what is parallel. Okay, so parallel means, let's say this point is A, this point is B. So now you tell me one thing, guys. How many ways I can go from point A to point B? I can go in this way, I can go in this way, I can go straight, I can go like this, I can go like this, and there are infinite number of ways I can go from A to B, right? Do you agree with me, everybody? Yeah, there are infinite number of ways. So if two ways are different, like let's say this is way number 1, way number 2, way number 3, way number 4 and 5 and so on. So what we say when we have different ways to reach from point A to point B, I repeat again, when we have different ways to reach from point A to point B, we call all those lines are parallel to each other. That means 1 is 2, 3, 4, 5, all of them are parallel. All of them will be considered parallel. So once we do resistances, this will be used. So please understand this now, so that when we do resistances, Ohm's law and all that, this will be used over there. Yes, I hope everybody is enjoying this class. Yeah, please let me know in the comment box, everybody. Looking for your comments. Come on. All right. Okay, meanwhile, let's go forward with our chapter. Okay, now this is the next part, electric circuit. Now what is an electric circuit? Electric circuit, see this, there is a circuit, we plot a circuit, everything is sorted out using the circuit part. Now what is a circuit? Circuit is a continuous and closed path. Remember, this is a very important statement, guys. Continuous and closed path. This is closed path. It means if it is rectangular shape, it will be closed. It won't be open from anywhere. Closed path. This is the meaning of closed. The closed means totally enclosed. If it is triangular, it can be just triangle. This is also closed. Circle is also closed. It can be any shape, polygon or any kind of shape, any random shape. But it has to be closed. Whenever it is closed, we call it, then only we call it circuit. Otherwise, the current will not flow and it will not be called circuit. All right. So next part is, okay, this is a diagram, schematic diagram of electric current compromising. Okay, what all the things are there in electric current, electric circuit? Okay, so we have, okay, I'm just pointing it over here. Let me change the color. Let's say this time we take red. All right. Okay, red color looks good here, right? Isn't it? Yeah. Blue is also good, by the way. Agree with me? Yeah, everybody? Yeah? All right. So let's take what is a circuit. So what happens in circuit? In circuit we have, there is a cell in circuit. There is one electric bulb, or it can be resistance or any load or TV or fridge or anything else. We call it bulb over here. For our purposes, we measure it by bulbs. Okay. There is one ammeter. Ammeter we can put or we cannot put. It doesn't matter. Okay. It's written over here. We just put an ammeter or may not put. And there is one plug key, so that we can just switch off the circuit and switch on the circuit. In your home, in your home, when you have to switch on the light, what do? You go and switch on the switch, right? What do? Just switch on and you have the light comes up. What's happening? As soon as you switch on, the circuit gets completed, it gets closed. The switch looks like this in this circuit. The switch looks like this in this circuit, guys. As soon as you press your button, this closes. This closes as soon as you press the button. And as soon as it closes, the electric current flow and you have a light over there. All right. So what's happening over here is that, how does a circuit looks like? It will be like this. There will be one cell. Cell is denoted as this. This is a symbol of cell. You have studied in 6th standard, 7th standard, 8th standard, 9th standard, all these standards, everywhere this particular thing was used. Okay. Now this is cell. There is one cell. Then we have one plug. We call it key. Then we have one bulb, all right, or in fact bulb I can write like this. Resistance, I can put anything, any resistance over here. This also shows as there is a bulb or resistance or something is the same thing. And after that there is one ammeter, this is a symbol of it, and then we close the circuit. This is not an important part. Ammeter is just to measure how much current is passing through. That's it. This is not an important part. Important parts are, we have battery which gives potential difference, and we have resistance which gives us that current. So there are only three things we are interested in. One, current, resistance and voltage. In this chapter we are interested in these three. So let me go back to my initial diagram, what I showed you. Alright, so what's happening inside the circuit? Let me show you. What is battery doing? What is resistance doing? What is current doing? Okay, let me go back to my initial slide. Those people who have come late, okay, please have a look over here. This is exactly what is going on in the circuit. This is exactly what is going on in the circuit. You can see that. In your circuit, this red fellow is our resistance. This is our potential difference. PD is potential difference. For it is coming from cell. It's coming from the resistance, the bulb or whatever you call it. So this is our current. So potential difference is trying to push the, is trying to push the current, and resistance is trying to stop it. This is what exactly happens in a circuit. Please take a screenshot of this. It will be really helpful for you to visualize what's going on inside the circuit. Okay. All right. Let's go back to our circuit. Come on, if you're enjoying the class, please give me a thumbs up. Everybody, please give me a thumbs up. See, we're doing really hard work over here. We have a whole unit working here and we are really doing hard work for you guys. So please give us a thumbs up so that, it will encourage us. Please like this and comment and do whatever it is to motivate us so that we can make more videos like this. All right. Okay. Let's go back to our circuit part. So let's go back to our circuit part. What's happening in our circuit? Okay. So this is a symbol of circuit. This is what's happening in circuit. Now, as soon as this switch is closed, the electric current starts. Potential difference is pushing the electric current and it's passing through this and going over here. This is what's happening inside the electric circuit. All right. Thank you very much. Okay, Tanush, Ruchita, Savita Bhatt, Rayansh, thank you very much, and those everybody, and thank you for everybody. I couldn't name everybody, can't read because there are a lot of people out there. I can't read everybody's name, but thanks a lot for your comment. All right, let's go further. This is our electric circuit. Okay, symbols and component. We need to know what is the circuit. This is how the cell looks like. This is how the resistance look like. There you don't need to remember much. By the way, this is how the bulb looks like. All right. This will be your bulb. All right. This will looks like, the bulb will look like this. though it's not, in reality it's not bulb, but this is how this will be shown in the circuit. No need to worry about it. We'll discuss that once we do some problem, numericals, you will see. Okay, we have, again, those who join late, I'm going to tell you, this class is going to be 2 parts. This revision class is going to be into 2 parts. Part 1 we are taking today. We'll be covering up till Ohm's law, resistances, and few MCQs and questions, past year problems, and remaining part, energy and stuff, we will be doing on Monday. Okay, please take both the classes seriously. Please understand this. If you have not studied so far, now you can understand everything about this chapter. Okay, I'm explaining everything. Whatever you are seeing over here, CBSE on your board exams, you will only have questions from here. You will not, the examiner cannot go anywhere else, because these are the most important points. All right guys, please make a note. Keep on taking a screenshot of everything. Make your notes. Take a notebook. Write it down. Do whatever you want, whatever you can. This is very easy topic, very high weightage in this. Very high weightage of this. Okay guys, let's go further and let's go hit. Okay, all right, now we come to, there is something called Ohm's law. So we got the circuit done. So initially we started off with electric current. Electric current is nothing but flow of charge. Then we understood what is it, what is our potential difference, the direction of electric current. Okay, now let me tell you what exactly resistance is, by the way. Okay, let me tell you what exactly is the resistance is. Okay, we know that we have atoms, right? Okay, we have atoms. Atom has nucleuses, right? Just explaining you guys, just giving you view, how does it work, how does the resistance work, so that you can visualize what is going on. All right, so there is a nucleus. In nucleus we have all the protons and electrons are moving around it. So in a conductor, what happens is, in a conductor, there is a conductor. We put it in a cylindrical way. Okay, conductor can be any shape. Cylindrical is the most common one. Okay, all right. So what's happening over here? When potential difference is applied, plus and minus sign indicates the potential difference is applied. Okay, that means this cylinder is connected with the battery. Now what's happening over here? Electrons will start to move towards positive side. Why? Because this is negative. Electrons are negative charge. So electrons are negative charge, right? All the electrons are negative charge. We know that positive attracts the negative charge particle. So electron starts to move this direction. All the electrons start to move in this direction. Why? Because there is a positive potential difference over there. Now these electrons, now there are millions and zillions and zillions and zillions of electrons out there. Okay, actually in 1 meter cube you have 10 to the power 28. These many free electrons are there. 10 to the power 28 means 28 zeros after 1. You can't even count. After 6, 7 I lose my count actually. I think everybody loses it. So 28 zeros after 1. These many electrons are there. These many electrons are straight away walking. And this is in 1 meter cube, guys. When they start moving, so what happens? Lot of them, they collide with the atoms. Lot of collision happens because there are atoms which are not moving, right? There are atoms which are not moving. Let me put atom with blue. Okay. All right. Let me see. Okay. Let me see. Okay. This is blue. Okay. This came over here. So there are atoms. Atoms are in blue over here. You can see. So these electrons strikes the atom. These electron and they go and they strike the atom. This collision, what it does, because of this collision, the electrons, some electrons, let's say if there are 10 to the power 28 this electron, now 10 to the power 15 atoms. Atoms are way less in number, but still there are considerable amount of atoms out there. So what happens? Electrons strikes the atom and they stop moving. So lot of electrons, they collide with atoms, they stop moving. This collision is nothing but resistance. So this collision is nothing but resistance. If somebody asks you resistance, now you know, you can explain that person. Even if you write this in CBSE board, it is acceptable, it's absolutely correct. Okay, write in your language. If you understood it, write in your language. Okay, guys, please give me a thumbs up if you like the video so far. If you like the class, please give me a thumbs up. Everybody. Yeah. All right. Let's go and hit. So this is how it works. This is how the resistance work. Now we are going towards, there is next point is very important. We call that Ohm's law. Okay, let's see that. What is Ohm's law? On your screen you can see that. Now what is Ohm's law? Ohm's law gives us relationship between potential difference and the current. It means how much is the potential difference and how much is the current in the circuit. How much is each? How will we calculate it? That calculation, that relationship is given by this man. His name was Ohm. Not our India wala Ohm. It's just Ohms, OHM actually. Okay. So this was a scientist who found out this relationship. He said that potential difference V is proportional to current. This is what the relationship he gave. And he used a constant called resistance. V is equal to I into R. This is a very important relationship. It's a very important relationship. In fact, a lot of questions are asked, numerical problems, everything from your board exams on this. I know it is very primary. You have studied this before. A lot of you already know it, but once we do the problem, we'll see. Okay, so this guy Ohm, we gave this V is equal to IR, where V is potential difference, I is current, and R is resistance. I hope it is absolutely clear. Yes? Yeah? Take a screenshot. Please note down everything that we are doing over here. This is what the Ohm's law is all about. Now we'll study a little bit about resistance, because this is where the question comes in exam. We'll study a little bit about resistance and all. I hope you guys are liking the video. Give me a thumbs up. Everybody, please. If you like it, please give me a thumbs up. Yeah? Okay. Please, everybody. All right. Moving to the next topic. All right. Okay. Yeah. So that was our Ohm's law. Okay. Now resistance. Let me give you something about resistance. Okay. All right. Let's say resistance. Ohm's law is all about resistance, guys. You understand Ohm's law, you understand resistance, you understand this chapter. So as we saw our figure, it says the job of resistance is to stop the current. Current means flow of electron. So the job of resistance is stop the current. Okay. So resistance depends upon what? First question comes is, what does resistance depends upon? So resistance depends upon, we call rho L by A. Now what is this rho L by A? What is this thing? Okay, what is this? So rho is our resistivity. Resistivity. Now what is this resistivity? Resistivity, rho is RHO. It is written in this, guys. Okay, this is RHO. This is how it is called, RHO, rho. Okay, rho. So rho is resistivity. What is resistivity? See, every material, let's say plastic, let's say metal. Now you tell me, just think about it. Current, if you want to pass current through metal, want to pass the current through plastic, which one is easier? Obviously through metal, right? Obviously through metal. Current cannot pass through this plastic. So what's happening over here? We call that resistivity of metal is more than, okay, we call it, okay, the resistivity, it means the stoppage, resistivity of the glass. Sorry guys, so the resistivity of the glass is more than metal. So it depends upon the material. Okay, so resistivity of the glass, okay, or more than metal. Okay, so this is how the resistivity is done. This is nothing but, it only depends upon type of material. This is what you have to remember, type of material. So resistivity depends upon type of material. Our main R, resistance depend upon what? Type of material, length and area of cross section. Now what is length and area of cross section? Again I will go to cylinder. So this is our cylinder. Let's part cylinder. So the length of the cylinder, and let's say if I see from here, my eye is right here, okay? If I see from here, I will see this area. So this area is called area of cross section, and this length is L. So resistance depends upon length. It means if the length is more, resistance is more. Resistance is inversely proportional to area. That means an area formula is what? This is circle, right? So I can write area is equal to pi r square also. Is it not? Area of the circle is what? Pi r square. Now resistance is inversely proportional to area, and resistance is proportional to the type of material or resistivity. This is where the question comes from, guys, in your CBSE board exam. This is where the question comes. Please take a screenshot. Please note it down. Please note down everything over here. Everything that we are doing is extremely important in our class. Question will come from this. I can give you in writing. Question will come from this. Yes, these are the most important topic, and I'm trying to explain you everything over here. Everything right from scratch. So people who have not done this chapter, they can also do this chapter very easily. It's very easy. You can just watch this video. After our class gets over, I will ask you, please watch this video again and again and again until you get it through. And those who already know, just watch it on 1.5x or 2x speed, so that you at least grasp the formula, everything that we speak about, and take a screenshot of all those notes. Those are very important for your examination. All right. Okay, I will keep on telling you what is more important, what is less important. So this slide, which is behind me, this particular thing, rho L upon A, question comes from this. We'll do the problems. Okay. What kind of question comes? They will give you, okay, if length is more, what happened to resistance? Simple. It will be more. Why? Directly proportional to resistance. If area is more, what will happen to resistance? It will decrease. If the radius is more, if the diameter of this cross section is more, what will happen to resistance? Again, decrease. Why? Inversely proportional. This is how you have to study this chapter. Okay, guys? Yeah? Resistivity is a type of material. Is for one material there will be one resistivity, for another material there will be another resistivity. Okay? It does not depend upon length or area or anything. Okay? I hope it is clear. It depends upon temperature though, resistivity. Okay? We'll discuss that as we go further. But as of now, this formula is very important. I hope it is clear to everybody. Yes? Let's go ahead and do some more part over here. Okay? All right, as I just said, resistance depend upon what? Length, area of cross section, and type of material. And resistivity is rho. Okay, you can take a screenshot of this. Also, you can read about it. Okay, and you can go ahead about it. Okay. What is the SI unit of resistivity? This is a very important chapter. Ohm meter. What is the SI unit of resistance? Is ohm. So resistance SI unit is ohm. So it is known as this. This is how it is shown. This is resistance. Okay. Yeah. I hope it is absolutely clear to everybody. Yeah, please give me a thumbs up if you can understand this. If you're finding this class useful, please give me a thumbs up. Yes. Everybody, please give me a thumbs up. All right. Let's go back and let's understand a little bit about resistance more, which comes in exam, the examination point of view. So the question about resistance is, first there are two types we put resistances. Okay. One is your series combination of resistance. Now what is this? How will you find what is series combination? What is the series combination of resistance? Those who know, very good. But those who do not know, after this they will know. All right. So what happens? We take resistance, let's say three resistance, R1, there's another resistance R2, another resistance R3. Let's say this point is A, B. This is resistance number R1, resistance number R2, resistance number R3. Now what's happening here? Now how will I know this is series combination or parallel? How will I know? You start walking from A. Think about it. You sit over here and start walking. In how many ways you can go from A to B? You can see this. There is only one way over here. You can see there's only one way plot. So all the resistances which are coming on your way when you are walking from A to B, they all will be in series. In series combination, the equivalent resistance is R1 plus R2 plus R3. Need to remember this, very important for your board exams. Numericals come on this. All right. So let me show you one question. Let's say this series combination of three resistances. This is 5 ohm, this is 10 ohm, this is 5 ohm. Now what is R equivalent between A and B? This question was asked in exam. So what will be my R equivalent? Let me change the color. My R equivalent in this case is going to be, I start from A, go to B. What I will find? All three resistances are coming on my way, and hence all three resistances are in series. So this becomes 5 plus 10 plus 5, that makes it 20 ohms. Answer. This question is from CBSE past year problem. Yeah, this is how easy the problems are. All right. Yes. Clear, everybody? Is it clear? All right. Okay, let's go with our next part. That is, okay, this is our series combination. Okay, and next part is our parallel combination. So what is the parallel combination we have? Parallel combination. So what is parallel combination? Let's say we start from here. This is my point A. One resistance here, one resistance here, one resistance here. This is B. Now this is, let's say, my R1, R2, R3. Now if I start from A, how many ways I can go from A to B? Clearly, I can go from A to B in 3 ways. This is my way number 1. I can go like this. Way number 2, I can go like this. Way number 3, I can go like this. So 3 ways I can go. So we call it parallel combination. So in parallel combination, my R equivalent is found as 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is where the question comes from. So let's say if the question comes, this is 6 ohm, this is also 6 ohm, and this is also 6 ohm, and all three are combined like this. Now I can clearly see these three are in parallel. Why? There are 3 ways I can go from A to B. So what's my R equivalent? 1 by R equivalent I need to find. It will be 1 by 6 plus 1 by 6 plus 1 by 6. Take the LCM 6. On top I get 3. So 1 by 2, which is 1 by R. Don't forget to reciprocate it, okay? This is where you make mistake. So 1 by R equivalent is 1 by 2. So it gives me R equivalent is equal to 2 ohm. Answer. I hope it's clear. I hope it's clear to everybody. Yeah? I hope it's clear to everybody. I hope you're enjoying my class. I hope you are able to understand. I'm starting from basics. Those people who do not know, who have not done this chapter before, or they've forgotten, now you know. Now you can very well understand this, what we are doing, okay? Any question which comes in exam will be from here. All right? Okay? All right. Ohm's law. Yeah, Ohm's law sikha denge aapko. I'm seeing the Ohm's law. Please look it over there. Just see this video, guys, okay? This is a live session. Okay, I have to go forward. Okay, just see this video again. Write in the comment box whatever your doubt and I will come back to you. See this video again, guys. See this video again. I've explained everything in clearly. All right? Yeah? Okay. All right? Pakka will teach you. Don't worry. You watch this video again, you will see how the Ohm's law is done. I've already spoken about Ohm's law. Shri? Okay, Shri? Yeah? I've already spoken about Ohm's law. सीख लोगे आप Ohm's law. जो भी हम करेंगे उससे. Just learn from there. Okay? Now let me go forward. Yeah? All right. So this is the factors which are affecting it. Now let's do one problem related to Ohm's law. All right. Let's take this problem. This is my A, this is my B, and okay, one second, let me just put this properly. Okay. All right. Okay. So let's take this way, and this is my A, this is my B, and this is, let's say, 5 ohm. This is, let's say, also 5 ohm, and this is, let's say, 5 ohm. Examiner asks, okay, this is a question that you need to know. Okay. How to solve this problem? Question is, we need to find what is R equivalent. R equivalent we need to find between A and B. Between A and B. How to find that? So it's very simple, guys. Just see over here. First, we need to find out, okay, we can see how many ways I can go from A to B. So one way is I can go from here. This is my one way. I'm just changing the color, okay, so that you guys can understand it. So this is one way. This is second way. And then this is the common way. This is the common between 1 and 2. So first thing is leave the common. Just leave the common. All right. Just leave the common one. So what's happening over here is 1 and 2. These two are in parallel. So what is my R equivalent for these two? So my R equivalent for these two is 1 by 5 plus 1 by 5. That comes out to be R equivalent is 5 by 2. That is 2.5 ohm. For this part I got 2.5 ohm, guys. If you can see 2.5 ohms. This part. And this 2.5 ohms, I can redraw the circuit like this. This circuit is redrawn in like this. I put it over here, one resistance, another resistance. So this is 2.5 ohm, this is 5 ohm. So if you see this part of the resistance, I have confined to make one single resistance using the parallel combination. And here these two are in series. So R equivalent between A and B is going to be this plus this, 2.5 plus 5, that gives us 7.5 ohm. Answer. This is the kind of question you will find in your LAQs. Those long answer question, right? This is the numerical. Okay. This kind of numerical you will find in SAQs also. Okay. Depending upon the quality of the question, whatever exam. Oh yes, lot of students have given answer 7.5. Very good. Yeah. What's your name? Dhanusha. Dhanusha, very good. Okay. Keep on posting it. Very good. 7.5 is the right answer. All right. Okay. 7.5 over here. All right. Let's go do some problems now. Okay. Let's do some problem. Some multiple choice question. Okay. Guys, I want you to do now the problem. Okay. Yeah. I want you to do the problem now. Let's go with, okay, first question. First question is, please on your screen, specific resistance of wire. Specific resistance of wire depends upon what happens. Specific resistance of wire, it increases with temperature, decreases with temperature, independent of temperature, or first increases and then decreases. Come on. Okay, I'm waiting for your answers. Let's see who can answer this. I'm waiting for your answer, guys. All right, everybody, please participate. Come on, go for it. Yes, this is for your own good. All the warriors, CBSE, going for fighting. Okay, go for it. All right. Okay. All right. So the answer of this is increases with increase in temperature. This question is past year CBSE question, guys. Okay. This increases with increase in temperature. All right. Yeah. Okay. Clear? Okay. Okay. Fine. All right, guys. Okay. Very good. Okay. Let's go with the next MCQ. Okay. Let's go with next MCQ. All right. In an electrical circuit, three incandescent bulb A, B and C rating for 40 watt, 60 watt, 100 watt. Okay, there are three bulbs, okay, respectively are connected in parallel to an electric source. Which one of the following will happen? Okay, there are three bulbs, they are connected in parallel. Now what will happen? The brightness of all the bulbs will be same, first. Second, brightness of bulb A will be the maximum, brightness of bulb B will be more than A, or the brightness of bulb C will be less than that of B. Just read it carefully. It's very easy question. Okay, let me give you a hint. Brightness depends upon power consumed. So which has more power among them? Whichever will consume more power will have more brightness. All right. So lot of you are answering. Okay, let's see. Okay, I'm getting answer as A. All right, let's go further. Okay, let's see other people. Yeah. So one is saying brightness of all the bulbs will be same. Is it the right answer? Come on, everybody. Come on, everybody. Tell me. Is it the right answer? No. I just told you brightness depends upon power consumption. This is 40 watt power, 60 watt power, 100 watt power. So which has most power? 100 watt is the highest power you can see. Then 60 watt, then 40 watt. So power consumption will be more in this, then this, and then this. And whichever is more, whichever will consume more power will be more bright. So the answer of this question is brightness of A will be. I hope this part is clear. Yes. Okay, very well. Yeah. Okay. Let's do next problem. We are running short of time. Let's see. Okay. When a potential difference is applied across the two ends of a conductor, then the electric field due to applied potential difference exists inside the conductor, outside the conductor, both outside. These are the very important questions, guys. Okay. Yeah. All right. Okay. Yes, you are right, Sri. Absolutely correct. All right. Yeah. Please do this problem now. When a potential difference is applied across the two ends of a conductor, then an electric field due to applied potential difference exists. Where is the electric field exist? Inside the conductor, outside the conductor, both outside and inside the conductor. Okay. Yeah. Come on. Answer. Answer this, please. Yeah. Okay. So the answer of this question is yes, absolutely correct. It will be inside the conductor. Okay. So electric field is inside the conductor. Okay. These are the tricky questions, I know. Okay. But these are the very important questions for your board exams. All right. So guys, I am just stopping right now. I'm just stopping right now as of now, and we'll be taking the remaining session in our next class. Those, please watch this video again, and if you have already seen, watch it in 2x speed. If you have not seen, if you're new, watch it slowly. But see you again on Monday evening, and we'll complete the remaining part of the chapter. I hope you enjoyed this particular explanations, chapter, everything, and we'll see you again. Thank you very much. Right. Yeah, Sri, what happened? Why you want to die? What's wrong with you? All right. Anyways, I'll please come back on Monday and I'll answer your question personally, everything. Okay. Thank you very much. We take a leave and see you again. Bye bye. Yes.